Yeah, let's do a pretty simple pressure problem, because I can't think of a way to make these more difficult. I'm sure there is, I just need more practice. Um, so we'll have some water, maybe fresh water, I don't know, and we're submerging, so it's like a lake or something, and we're submerging in a cube. And we know the volume of this cube. Okay. We know how far down we submerged it. This is often called H, which seems a little backwards to me, but whatever. So we know the depth we've submerged it to. We know the density of the water. And we know that we're on Earth around sea level, so we know the pressure out here is atmospheric pressure. Okay, but oh, sorry, that's a row. Atmospheric pressure. There we go. So what we want to do is find the average force, or just the force from being deep in the water on one of these sides. So we'll find the force from, yes, so say on that side, doesn't really matter. Okay, so the way we're going to solve this one is, well, this seems like a pressure problem, right? And you get a feel for them. So the way we can get force from pressure is, well, we know that pressure equals force over area. So if we rearrange this, we get force is equal to pressure times area. So if we can find the area of the side of the cube here, and if we can find the pressure that we're at, then we can find the force. So first let's talk about pressure. So to find the total pressure, you need to add together the pressure that, the initial pressure sort of that you started with, which is the atmosphere up here. So the atmospheric pressure is contributing to the pressure on the box because it's sort of like all the air up here is weighing on the water. So that plus the pressure due to being deep in the water, which is calculated by the density of the water times the acceleration of gravity times the depth. Alright, so that's how we can find the pressure. So we know the density, we know gravity, we know H, so we can definitely find this pressure. Okay, good. And now the only other thing we need to know to calculate the force is the area. Now that's tricky, a little tricky, because I didn't give us the area, I gave us the volume of the box, right? But I also said it was a cube. So let's look at this. I'm just going to draw a picture of the side, the shaded side over there. So I'm trying to find this area, right? Well, if the whole thing was a cube, then I know I can find the side length, because the side length is going to be the cube root of the cube, right? Like the square root, but cube root of this volume will give me a side length. And I know that this is going to be a square because it's off of a cube, so all I have to do is multiply by another one of these cube root of volumes. So the cube root of volume squared, essentially. Seems a little bit weird, right? But that can also be written as the cube root of volume can be written as volume to the 1/3. And so if we have volume to the 1/3 times volume to the 1/3, we get volume to the 2/3. Alright, so that is the area of the side of a cube, is its volume to the power of 2/3. Weird, right? So that'll get us our final answer. Force will be equal to atmospheric pressure plus density times gravity times depth times the 2/3 of the volume in this case. Alright, so we just used the equation for finding pressure at a certain depth under a certain density liquid, and we used the definition of pressure to rearrange and solve for force. And we had to leave a little geometry with area, but that's not really much physics, is it? It's just kind of math and geometry. Okay, there you have it.